Okay, we're going to continue on to page 7 in our interactive notebook. First thing you want to do is take page 7 and fold it. You're going to still be able to see the title 1-4 perimeter and area in the coordinate plane. So on the front cover of your notes, you're going to see all the different types of polygons and how to name them by the number of sides that they have. You're also given 2 vocabulary words. You can have a convex polygon or a concave polygon. And then down at the bottom is just a reminder of the formulas for perimeter and area of triangles, squares, and rectangles. So you're going to be using all of this information to complete the examples inside. So opening up your notes, the very first example, find the area and perimeter of a rectangle with the following coordinates. So the first thing you're going to have to do is plot those coordinates in the coordinate plane just so that you can get a visual of what this is going to look like. So starting off with point D, you want to go to the left 2, up 6. Might be a little off the grid, but there's point D. And then point E is to the right 4, up 3. Point F is to the right 2, down 1. And point G is to the left 4, up 2. So if you connect these points here, you'll get an idea of what this rectangle is looking like. So notice that in this rectangle you have opposite sides that are going to be equal. So when you're calculating perimeter, understand that opposite sides are equal, so when you add them up, you'll have 2 numbers that match up for DE and GF, and then 2 side lengths that match up for DG and EF. So let's do perimeter first. So you're going to have to get the distance between points D and E, or calculate the distance between points G and F. You're going to get the same answer no matter which pairs of points you pick. So I'll model this with points D and E. So point D has coordinates -2, 6. Point E has coordinates 4, 3. So you're going to use the distance formula to calculate the distance between those 2 points. So DE, the distance between those 2 points, is the square root of 4 minus -2 quantity squared plus 3 minus 6 quantity squared, all under the radical. Okay, 4 minus -2 is 6, and 6 squared is 36. 3 minus 6 is -3, and -3 squared is 9. 36 plus 9 is 45. And the square root of 5 can be simplified. It can be put into simplest radical form, because 9 can go into 45 5 times, and the square root of 9 is 3. So this simplifies to 3 root 5. So that means DE and GF both have a distance or a length of 3 root 5. So I'm just going to label that 3 root 5, 3 root 5, because in a rectangle, opposite sides are the same length. Then I'm going to do the same thing so I can get the distance between DG and EF. So it doesn't matter if you use the distance formula between points DG or use the distance formula to get the distance between E and F, because they're going to be the same distance. So I'm just going to use D and G. So I'm going to write down the coordinates of those 2 points. And again, that's given to me right here. And then I'm going to plug those into the distance formula. So the distance between points D and G is the square root of -4 minus -2 quantity squared plus 2 minus 6 quantity squared, and that's all under the radical. So -4 minus -2 is -2, and -2 squared is 4. 2 minus 6 is -4, and -4 squared is 16. So dg is the square root of 4 plus 16, which is the square root of 20. And that can be simplified because 4 can go into 20 5 times, and the square root of 4 is 2. So this is 2 root 5. So that means that DG and EF both have a length of 2 root 5. So I'm going to go ahead and fill that in. And now that I know the length of my sides, I can now find the perimeter. So perimeter is just adding up all 4 sides. So perimeter, I want to take DE plus EF plus FG plus GD. So I'm just adding up my 4 sides of the rectangle that I have in the coordinate plane. And then I'm just going to substitute those values in. So I just calculated DE to be 3 root 5. EF was 2 root 5. FG was 3 root 5. And GD was 2 root 5. So combining like terms, these are all root 5. So I can take 3 plus 2 plus 3 plus 2, add those together. So it's 10 root 5. And since we're in the coordinate plane, this is not inches, centimeters, this is just units. So I'm just going to write 10 root 5 units there. So that's my perimeter of this rectangle. And now I have to get the area. So to get the area of a rectangle, it's just length times width. So go back to your picture that you drew and identify the length and the width. So the length is 3 root 5 and the width is 2 root 5. So I'm going to multiply those together. 3 root 5 times 2 root 5. And if you're not confident in your operations with radicals, you can always put it in a scientific calculator. So 3 root 5 times 2 root 5 is just 30. So my area is 30. And similarly to what we did with the perimeter, this is just measured in units. So area is square units. So that's how you would calculate the area and perimeter of a rectangle in the coordinate plane. So notice how the distance formula that we used back in the previous section now gets applied still now that we're calculating area perimeter in the coordinate plane. Okay, example 2. We're now going to have a triangle, and all we're doing is finding the area. We don't have to calculate perimeter for this one. We're just going to calculate the area of the triangle. So first things first, plot your points. A is -4, -2. B is -2, 2. And C is 5, 1. And then connect those 3 points to form your triangle. Okay, so then I'm going to use the formula for area of a triangle. In case you forget any of your area formulas, they are at the bottom of that front page. So area of a triangle is 1/2 BH, where B is the base, H is the height. So area is 1/2 times the base times the height. So I have to figure out what the length of the base is and what the height is of this triangle. So my base is going to be AC. So you have to calculate the distance between those 2 points. So you're going to do what we did in the first example, but using points A and C. So A was -4, -2, and C was 5, 1. So if I use the distance formula, I'll get the length of the base of this triangle. So AC square root, you can do 5 minus -4 squared, 1 minus -2 squared. 5 minus -4 is 9, and 9 squared is 81. 1 minus -2 is 3. 3 squared is 9. So AC is the square root of 81 plus 9, which is the square root of 90. And that can be put into simplest radical form, because 9 can go into 90 10 times. And the square root of 9 is 3. So that's 3 root 10 for your base. So now that I know my base, I need to go in here and calculate my height. Now the height is not drawn for you, so you're going to have to go ahead and do that. So you have to draw in your height. And remember, the height is perpendicular to the base. So that's your height. So we know the base is 3 root 10. Now we have to calculate what the height is. So you have to remember back from algebra that if you have perpendicular lines, then the slopes should be opposite reciprocals. So just verifying, it looks like this point here, my height intersects my base at point X. So we'll call that point X, where the height intersects the base. And it looks like X has coordinates -1, -1. So it looks like X has coordinates -1, -1. So I'm just going to verify that by checking to make sure that the slope between A and X is the opposite reciprocal of the slope between B and X. And then I'll know for sure that that's perpendicular. So point A is -4, -2, and like I said, X looks like it's at -1, -1. So I'm going to apply my slope formula. For those of you that forget, it's y2 minus y1 over x2 minus x1. I'm going to apply that formula just to make sure that these are perpendicular. So y2 minus y1, I'll have -1 minus -2. x2 minus x1, I'll have -1 minus -4. So that gives me 1/3 as my slope between point A and point X. And then I'm going to do the same thing, calculate slope, but this time between B and X. So point B is -2, 2, and point X is still -1, -1. And I'm going to do my slope formula again, but between B and X. So y2 minus y1 is -1 minus 2. x2 minus x1 is -1 minus -2. So that gives me -3 over 1. So notice my slopes are indeed opposite reciprocals. 1/3 or 1 over 3 and negative 3 over 1, those are opposite reciprocals. So we know for sure now that BX is perpendicular to the base. So what I need to do is figure out the distance between B and X, and I'll get the height of my triangle. So I already know the length of the base. Now I need the length of the height. So I'm going to do the distance formula between B and X. So I'm actually going to erase this. I'll write that down further. I'm going to use this space up here to calculate the distance between point B and point X, which will be the height of this triangle. So now I'm back to the distance formula. So I have the square root of x2 minus x1, negative 1 minus negative 2 squared, plus y2 minus y1. So negative 1 minus negative 2 is 1, and 1 squared is 1. Negative 1 minus 2 is negative 3, and negative 3 squared is 9. So bx is the square root of 1 plus 9, which is the square root of 10. So my base is 3 root 10. My height is root 10. So that now allows me to plug in those lengths into the formula for the area of a triangle. So remember, area of a triangle is 1/2 times the base times the height, and now I know what the base and the height are. I know the base is 3 root 10 and the height is root 10. So it's 1/2 times 3 root 10 times root 10. And again, if you are not comfortable doing radicals without a calculator, then use one. 1/2 times 3 root 10 times root 10 is just 15. So the area of this triangle is 15, and then square units. So if you are doing triangles, just make sure that the base and the height are indeed perpendicular. And you might have to check that by using the slope formula and making sure those slopes are opposite reciprocals. All right, last example. We're going to get another triangle, but this time you have to see where the triangle is by graphing all 3 lines given and shading in the triangle that is created. So starting off first with y equals -5, that is a horizontal line. So go down to -5 on the y-axis and draw your horizontal line. And then x equals 2, that is a vertical line. So go over to x equals 2 and draw your vertical line. And now you have an equation in slope-intercept form. So remember, 7 is the y-intercept and -2 is the slope. So start at 7 on the y-axis. So go to the y-axis, go up 7, and then you're going to apply the slope. The slope is -2. So starting at 7, go down 2 over 1 and put a dot. Then down 2 over 1, put another dot. And keep doing this. Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1, down 2 over 1. So keep doing it until you run out of room, and then connect your dots. And that is the line y equals -2x plus 7. So you'll see this triangle that was created. And this triangle is actually a right triangle because you'll have the vertical line and the horizontal line are perpendicular to each other. So this makes the base and the height a lot easier to calculate than the previous example. So remember, area of a triangle was 1/2 times the base times the height. So your base and height are horizontal and vertical lines, so you're just counting now the units. So counting the units for the base is 1, 2, 3, 4. So your base is 4 units wide. And do the same thing, count the height, because this is a vertical line, so just count these blocks. 1, 2, 3, 4, 5, 6, 7, 8. So the height is 8 units tall. So now do 1/2 times the base, which is 4, times the height, which is 8, and that just gives you 16. So when your base and height are vertical and horizontal lines, it's a lot easier. If they're not vertical and horizontal lines, you're going to have to use the distance formula to get the length of the base and the length of the height before you plug it into the formula.